Okay. Well, I'm going to cede the floor. I've run my mouth enough. I'm going to cede the floor to Jared and let him continue on with. Is this the title? Can I say it? Optimizing for humans in the AI era, humanity in the loop. Thank you for your time.
All right. Thank you, everybody, for coming. I want to say thanks again, like Michael mentioned, to Motion, to Base, to Tech Birmingham. Um, really been long-running pillars of the tech community around here, and very appreciative for the opportunity to come up here today and have this venue to share ideas. All right. And the idea that I'm going to share today is just that, optimizing for humans in the AI era, humanity in the loop. A little bit about the man behind the idea before we get started. I'm Jared O'Neill. I'm a engineering manager at Shipt, um, which is quite a journey here. It's started out about 6 years ago on internal tools as an engineer. Started working doing management after that, and just recently started on GigOps. There's some of my team right here. Don't want to embarrass them or call them out, but they're over here. And a little bit of disclaimer to go with that. I work at Shipt. I do not speak for Shipt. All of the content, opinions, thoughts, hilarious jokes that you will hear, those are all mine. Don't let anybody else take credit for those, please. These are my two kids. This is Rowan, the robot, and Arlo, the chicken. And this is, they're kind of the reason why I work, right? Second part of that disclaimer is that this is not a tutorial on how to get a team to use AI. I see a ton of content about that, about driving adoption and things like that, or you know, uh, what all is out there, what sort of productivity gains are available. You can find that pretty much anywhere with a Google search, right? Um, what I really wanted to do today was take that opportunity that all the sponsors and Base and everybody's put together and kind of share this thought experiment that I've had over the last year about what working with AI really looks like and how we can improve it. Because I think what we can all kind of agree on is that this technology sort of emerged slowly, but the impact hit us almost overnight, right? The advancement in models, it went from pretty much gibberish to this is somewhat competent very quickly. And kind of going off of that, as new technology emerges, I think we often forget that we run into the same problems every time, right? AI changed the way we work, but I don't think it's changed, or perhaps it has changed a little bit about the way we view problems, but ultimately, um, at the end of the day, all engineering problems are human problems. And I think as we talk about this, I think you'll kind of see that one of the reasons why, if you're like me, you can't always get very consistent results. You can't really match the hype to the reality of this tool. Um, Something has been lost in that pursuit, and reclaiming that, I think, is a key to success. So, the way we're going to talk about it today is through a mix of things, technologists, sociologists, artists, because what better way to talk about humans than to talk about art and to talk about people? We talk about sociologists, and technologists obviously talk about technology, engineering, and so on. Um, like Michael said, this is 60 minutes, and I do want to make sure I get my point across. So I'm going to kind of start out with something that is rather on the nose, but I think this is sort of the big takeaway, right? Like if you have to leave in 30 seconds, I want you to walk away with this quote in your mind and this takeaway from it. This is Max Weber. Uh, he was a German economist, sociologist, amongst other things, banker, etc. He did a lot of different things. But in 1905, he said, "We've become specialists without spirit, sensualists without heart. This nullity imagines that it has attained a level of civilization never before achieved." Right? And to me, that was fascinating because I think it really summed up how, as an industry, we felt with the emergence of AI tools. And then when you think about it, you realize that when he wrote this down, less than 1% of homes in Germany had electricity. He never saw a movie with sound, much less a TikTok, right? He didn't even know what kind of brain rot we were in for. And he was talking about like civilization has decayed, right? Um, he saw a light bulb and just immediately said, "It's so over. Like we can't come back from this." But I don't know about you, 120 years later, I think that I have spirit. I think I've got heart. I don't think I'm null, though JavaScript may disagree. All right, I got okay. All right, there's bad news. If you didn't think that was funny, they just get worse. So you're welcome. All right. Um, but put another way is, we've played these games before, right? This was something that was said hundreds of years ago. It still feels true, but if we focus on doing things the right way, if we remember how to really build engineering culture around technology, then I think we're going to be able to get through this and get back into um, really making the most out of new tooling. Okay. So now you're probably thinking, Jared, how did you start reading about people and texts over 100 years ago and applying them to engineering and to AI? Why is this important? Why do you think about this at all? Why aren't you just reviewing code, right? I'm a manager, they don't let me really review code. That's part of the job. Maybe a good thing, right? But as a manager, it is my job to look at our culture and find ways to build engineering teams to get successful engineering outcomes, right? So this is kind of like my Roman Empire, right? This is the thing that like I think about all the time. I'm like on Wikipedia, you know, you'll hear a lot about that tomorrow, I imagine, right? And um, I'm just looking at this all the time and trying to find ways that we can really perfect this and make sure that my embarrassed team over here gets the best work done possible. And to tell you that story, to tell you how I kind of got this idea, and this is sort of what it felt like it was just about this time last year, actually. I hurt my back. I missed a couple weeks of work. It was a very strange thing. I had to have surgery. And when I got back to work, I felt like Cillian Murphy. And 28 days later, I woke up and like the world was totally different, right? It felt like this was I don't know. It was just suddenly we had Gemini enabled at enterprise level, right? We had Copilot enabled. Suddenly we were back into this phase like I talked about earlier, where that like how do we get people to use this? How do we make the most out of this? Was really the focus of software engineering culture across the world, right? Um, so yeah, I woke up and I started walking around the the office metaphorically, and it was a shock. And one thing that became apparent very quickly, and I think you'll see this throughout the day, right, is that there's more to LLM assisted engineering than just getting code from a model, right? There's more to this job than just generating code as fast or as much code as you possibly can, right? And the reason we do that, the reason we're trying to hunt this whale, so to speak, is because we know that there are ways to be faster. There are ways to get better, right? You can look at these numbers, they speak for themselves. I think 33% increase in tasks completed per developer. That was measured over a quarter. Increase in delivery throughput. I think that was also measured over a quarter, and 15% decrease in small feature time to close. And these were stats gained from telemetry, right? These were not self-reported. These were, backed by actual math. On the other side of that is we also know that, like I kind of talked about earlier, there's not been a very consistent outcome for a lot of these things. There's a lot of stability, reliability issues that come with working with this AI tool. 40% increase in code churn. That's code that basically has to be pulled back or changed very quickly after it's released. 1.7x bugs in logic per PR, and 2.5 times as many incidents per PR. I think when you think about engineering culture, when you think about engineering as general, when you ask my mom, like, what does your son do? This is sort of what she pictures, right? And this is what a lot of us maybe also thought about ourselves, right? We kind of thought we were in this hands-on keyboard mode all the time, and that is, I think, one of the reasons why we're struggling with this AI adoption, right? Living in the post-AI world. Um, on average, historically, only about 15% of the time were engineers actually working in an IDE, right? So about 15% of the time, so that's 50, 60 minutes a day where engineers actually sitting around typing code in VS Code or Sublime or whatever, right? So the truth is that most of your job actually probably looks like this. complete with the jazz music and everything, right? Um, Maybe you're a little bit smarter than George. Hopefully, you're a little bit smarter than George. But the point of this is that I think we spend a lot more time in an abstract place than we give ourselves credit for when we're doing engineering, right? It's not just like cat on keyboard GIF, right, where we're just hammering away at the keys as fast as we can. There's a lot of thought, there's a lot of collaborating with your peers, right? 85% of the time you're doing stuff like reviewing code, reading books, learning, eating pizza rolls, like all the things that really make up really good engineering culture. And when we simply focus on increasing code, we don't actually increase positive outcomes, right? More code is not better. Uh, I was talking with a coworker about this the other day, and they mentioned there's an episode of The Simpsons where they realized that traffic actually moves fastest through yellow lights. So they make all lights yellow to help improve traffic. And obviously, that did not have successful outcomes. I also saw someone say once that a car moves fastest when it's falling off a cliff, right? Not successful outcomes there either. I think, Thelma and Louise will tell you that. Um, but the point is, right, that 85% of the time is something that we we used to sort of mesh and used to be kind of embedded with the way that we generated code, right? And when we move to this automatic, from the box code, we lose what this Danish computer scientist, though he wouldn't have wanted to be called that, he preferred datologist, information scientist, or pretty much anything else. Peter Nauer had this concept called programming as theory building. He wrote a paper about it in 1985. Um, and like I mentioned, like the reason I bring this up, the reason I mentioned the timing and include this great like photograph of him is because these are not problems or thoughts or concepts that are new to AI, right? This has always been sort of a concept, something that's been worth thinking on in computer science. So a little more detail on theory building, like what it is. Peter now writes in that paper that essentially a theory is how a software engineer maps the problem of the user onto software, right? He said that code and technical documentation are sort of artifacts of the actual solution, not the solution themselves. So in the paper, he mentions these three things: how the programmer can explain how the program relates to the affairs of the world, why the programmer can explain why each part of the program has been given its specific shape, defending the choice against alternative designs, and where the programmer is uniquely capable of altering the code in a way that remains consistent with the original design philosophy, right? So can you explain and defend your decisions, your architecture, your code, and when you come into conflict in some way with the solution that you have, are you able to correct that mental model as well as the software that represents that solution? And where this comes into conflict today is we have value maxed, to use the industry language, so to speak, right? Code generation, thinking it's the whole job, right? We've forgotten that 85% of the time we were building culture, we were thinking about problems, we were building these theories, and then kind of having that represented in the way that we generated the code. And that's something that contributes just as much to those successful outcomes as the actual code itself, right? And in order to course correct, so to speak, I think we need to talk about the management of large language model culture by talking about language. And I had to write this down because when I thought this sentence, I thought like I had a fever or something because it didn't make any sense. But then I wrote it down and I was like, okay, I can remember this if I write it down. So there's a lot to unpack in that. Um, and what better way to talk about language than to talk about my friend Bill? You may remember a quote from Romeo and Juliet: "What is in a name? A rose, or that which we call a rose would by any other name smell as sweet," right? Um, and this is something that I think Bill and I kind of disagree on, right? I don't know that that's necessarily true. Um, and that's something that I mentioned Peter now didn't like being called a computer scientist because he thought that the name computer scientist put too much emphasis on the machine. So that he really preferred to frame his science as the interpretation of data, right? How are we solving problems with data? How are we solving problems with information? When you call it computer science, he argued that you kind of lost some of the essence of it. And I think that's fair because if you called Shakespeare a quill scientist instead of a writer, you'd probably diminish some of the achievements as well, right? Um, and when we talk about names, and this is what was great was I had no idea Michael was going to touch on this so many times, but um, the concept of this idea that names and language shape the way that we view things or shape our understanding of reality even is linguistic relativity. And I thought it was great he talked about Birmingham area software enthusiasts instead of something like software engineers or whatever you want to call it, and talked about bad surprise. It's in the name, bad, right? So I thought that was a great segue into what we're going to talk about here. And once again, this is something y'all probably have heard before, right? Another problem that we run into in computer science is that idea of naming things, right? There are only two hard things in computer science: cache invalidation and naming things and off by one errors. So Phil Carlton, thank you, John. I appreciate that. All right. Phil Carlton, one of the lead guys over at Netscape, said this in 1995. All right. And the way that that shows up in engineering is through something like this, okay? Supplementary product ID. If you had a field or a variable with this name, you immediately have opinions of the importance, the subjects, and the primitive that make up this field, right? Opinions, but maybe it's not necessarily true, right? Because we know that that doesn't really scale, right? You start working in a code base and you start encountering semantic drift, right? Take the field amount, for example, all right? That could be a quantity, that could be a cost. User ID, this one drives me crazy because who is user? I don't know. The person doing the action, the person, like, is this a third-party SDK ID? I don't know. Status of what? The status of the order, the status of the product, the status of the shopper. It could be anything, right? And then order. This was something that came up recently that was a pretty fascinating discussion where we had something that had to happen sequentially, and we were calling it order, but obviously it shipped. Order means something like entirely different, right? So how did we, what's like, what, how do we talk about that? Do we call it sequence, Um, this is why language is something that's really important to us, and why uh, when you start putting language in the hands of the machine, you kind of lose something. Because when we talk about AI, we think about it like this, right? We think about it like data, we think about it like Locutus, right? We think that oftentimes, because this tool is so efficient, that it's doing some sort of rationing or reasoning that it's really not, okay? Because AI actually really looks like this, right? If there's just thousands of dictionaries jammed into those shelves, that's kind of what you'd be getting. And this is called the anthropomorphic gap, by the way, right? And the thing is, we sort of fell for it, right? As an industry, I think it's very easy to fall into this trap. But once again, this is a conversation that humans have had time and time again. This is called The Treachery of Images. It's a painting by Belgian painter Rene Magritte. I think this is 1929. You look at this, and your first instinct is, this is a pipe. But if you speak French, then you know that on the bottom it actually says, this is not a pipe. Okay? And that's a little confusing. But, if you just think about it for a little bit longer, you kind of realize, okay, this is a painting of a pipe. This isn't a pipe. This is a representation of a pipe, right? In the same way, right, when you work with AI, you're not working with that senior engineer of, it's not doing those things. It's a textual representation of the things that maybe make up a senior engineer, not always in the right order with the right importance. And that sort of misunderstanding at times can lead to something called the fluency gap. And so there's tons of different definitions for this, by the way. It's really hard to pick just one, but if you aggregate them together, you will find something like this, which is the fluency gap is the divide between knowing how to consume AI as a productivity tool and knowing how to build with AI as an engineering discipline, right? This is kind of that difference between vibe coding and then coding with AI. So to give an example of how that shows up in our work, right? Remember Bill? Even Bill had moments of this. This is a quote from a character called Don Armato in Love's Labor Lost. Love's Labor's Lost. Yes, Love's Labor's Lost. And I'll read it for you because how can I not, right? Get on stage and read Shakespeare. But so it is, besieged with sable-colored melancholy, I did commend the black oppressing humor to the most wholesome physic of thy health-giving air, and as I am a gentleman, betook myself to walk. The time when, about the 6th hour, when beasts graze, birds peck, and men sit down to that nourishment which is called supper. And like most Shakespeare, right, this is very elegant language. This is, very, very fluent. It's very uh, it's deep, right? You look at this and you're like, there's a lot of meaning behind that, bro. I really understand what you're talking about. But when you look at this character and you actually decipher the quote, if you will, all this guy is saying is, I got bored and went on a walk at 6, right? And that kind of shows up in code in the same way, right? We start mistaking elegance for meaning. We start mistaking things like this. We start thinking, wow, that's really complicated. It must be good. And you know what? It even works. It compiles. Wow. Um, but I think we can all agree that there's probably a little more to good code than it compiles or it works. But those are very important in good code, I suppose. So something like this is really just written another way, this, right? And when you start working with these LLMs, you'll notice that they are very verbose, right? This is another side of that fluency gap, right? Is that this fluent syntax, good syntax, is often mistaken as something worth keeping. And that kind of leads us into another problem, right? Because the way that the machine will spit out language to you, like I talked about earlier, right? It kind of talks to you like a senior engineer, and it's very confident, and it's very and like I said, the code works, right? So it must be good. And this is part of a little something called the simulacra problem. This is something that once again, this is not new. This is something that we've talked about, I think, since like the 50s. The simulation of perfect competence masks the complete absence of a reasoning, judging, or valuing human mind. So what we start working with LLMs, we start prompting all the time, we start working through this. Suddenly the code is able to generate itself. And the way that we engage with this machine, it starts making us, we get a little complacent and we start thinking that there's a lot of things happening that aren't, right? We think that the computer has built that theory, as Peter now would say. We think that we have, in a way, understood the problem, mapped it into software, but that's not always the case. That's why we can't get this thing to be very consistent. So one of the ways I think about solving that is through spec-driven development, right? I don't want to talk too much about how to use AI. Like I said, this is all post-adoption. Once you're using AI, adopting something that's a little more spec-driven, there's tons of cool frameworks out there to do this. Um, it's pretty self-explanatory, right? Spec first, we write the specs before we write the code, um, and then we do the code. And what this really helps with is clarifying intent, right? This process helps us clarify the project's intent. So I want you to kind of think back to the senior engineering example. Um, when we think about something like, let's see, do I have this? Okay, we'll talk about this in a second here. But um, think about a senior engineer that is reading through, in this 85% of the time where they're not writing code, they're reading through reports from your experiential ops team, right? So they're basically reading customer feedback, and they read about a shopper who didn't get offered any orders last week. This could be, this is a shopper that's maybe just trying to shop a few times a week to make money to pay for books for school or something, right? That type of shopper got left out of the new offering update, and they're not able to get the books that they needed for school or something. So they're messaging you. Your senior engineers can see that, and they can understand, oh wait, if we mess up our regular expression or something, if we mess up the way that we include or provide the shopper capacity for something, that has real impact on people's lives, right? A machine cannot do that. And that's one of the reasons why you're seeing some of these inconsistent results. You're seeing some of these numbers, these bugs in logic. If you have twice as many bugs in logic, this sort of thing is going to happen twice as many times, right? Um, you're going to have to roll the code back. It turns into a whole thing. I've got a great story to tell you later. Don't worry. Um, the fluency gap kind of leads into synthetic debt, though, right? We start seeing this code. We start adding it to our repositories because we're so concerned with how fast can we get there. How now that we have code and we're thinking to ourselves, we have so much code, we can get it so quickly, this must be worth committing. And we start building up a backlog of code that we can call synthetic debt, right? And this is code that finds its way into your system that is not understood or maybe even known about by its human maintainers. Once again, we have seen this before, right? Edgar Dijkstra, this is a Dutch computer scientist, talked about this. This is a great quote. 1989, when you're in debt, you should stop spending, or yeah, when you're in debt, you should stop spending, right? If we wish to count lines of code, we should not regard them as lines produced, but as lines spent. Um, and this sort of leads us into existence bias, right? The mere existence of code can lead us to try to rationalize its existence, right? You prompt the LLM, you get the code, it works, it compiles. This must be worth pushing forward. Um, that is tricky, right? That's another trap, right? This is post-rationalization, right? We're trying to explain something not because it's the right answer, but because we already think it's the right answer, right? We're working backwards through this, okay? If you take that example I talked about earlier, right? Maybe there's a switch statement, right? And you look through it, it's very thorough. It must be accounting for all edge cases, um, but you don't know if it's hit the critical ones. You have a duplicated component. You start thinking, well, we must want to keep this decoupled, right? Um, and it's problematic too, right? Because neither of these things are inherently bad, right? We know that AI is very capable of making good code very quickly, but we're not always able to get the outcome from it, right? And that's because we're doing stuff like this. We're building up this synthetic debt, and ultimately we're building cognitive debt as well. Um, why I say something that has been perfectly said already. Margaret Ann Story, she had a post about this. I think it was a somewhat viral post, but you may not have seen it before, so I'll read it again for you. The notion that the debt compounded from going fast lives in the brains of the developers and affects their lived experiences and abilities to go faster, make changes, right? Um, this is part of a much larger discussion, I think, and we can get into that later. But um, when you start building up debt, uh, you need ways to pay it back, right? Because debt comes due. There will, this from working with technical debt. I'm sure eventually you will need to start finding a way to pay down for this. So um, the thing that I have to put it for, or the thing wow, okay, excuse me. The way I like to put it, right, is engineering culture as it stands, or this value maxing loop we're kind of stuck in, isn't capable of paying these debts on time. So what I like to do, or what I kind of suggest, is introducing a friction tax, right? When we've removed all the friction from generating code, right? We don't have to worry about it. We're not thinking about it. It's just sort of doing it itself, and that loss of friction um, isn't necessarily a good thing, right? Have you ever had bald tires on your car? Yeah, like a little bit of friction is needed to go somewhere. So we need a new approach. Because a great role model of mine once said, if you do things that you've always done the way you've always done them, you're going to get the same result guaranteed. And it can be really hard to progress, right? To move out of this loop because there's so much emphasis and there's so much desire to go fast, right? We've opened up this ability to build so fast that we really want to do it. Like as engineers, there's a saying, right, that productive engineers are happy and happy engineers are productive. You want to build, you want to create. Um, but creation isn't the end goal necessarily. The outcome is the end goal. And as we've talked about this, I think you have probably thought to any number of articles you've read recently about PR reviews and how this is the new bottleneck because we're generating code, we're moving it through the process, we're getting it all the way as close to production as we can, and then it's being slowed down in the PR review. And I thought this was a really fascinating take because, as far as I was concerned, that was like the whole point of the PR review, right? And this kind of always was the bottleneck because this is the last boundary to stop reliability issues. This is the last boundary to catch errors before you send that code out to your users, right? Um, so I think there's something fair to be said. This should be the bottleneck. You should be stopping here to think about things. But I also think when we want to keep up with that speed, when we want to continue to deliver software, because we would like to, stay in business, right? We'd like to keep having jobs, wouldn't we? So we want to find ways to move code that we can understand and is helpful to our users. And the best way to do that, I think, is to introduce something like a cognitive integrity threshold, right? This is something that, once again, I'd say you're probably already doing this, but you may not have a word for it, right? This is sort of a linguistic relativity moment of this is something you can take into a conversation with your fellow engineers and say, I don't quite understand what's happening in this code. I don't want to push this yet, right? Or I don't think you know what's happening in this code. I don't want you to push this yet, right? And the important way to adopt this, if you will, into your culture is simply having this conversation because there's so many different or ways to organize a team. There's so many different things that are important to your team and your outcomes. I won't prescribe the how, but I will tell you the sooner you can have this kind of discussion, I think the better results you're going to get. There's some other pieces I think that you can tack on to your PRs. Additional complexity rules. If you weren't already doing complexity linting, this is a great time to add it to your team's PR agreement. Another thing that you are probably already doing, but the formalization of it is maybe a little scary, right? Is pair reviewing. I know, to talk about doing things before, right? It's 2010, right? And pair programming is like everything anybody can talk about. Um, Pair reviewing, it kind of gives people that same fear of pair programming, but um, your senior engineers are probably already doing this. You're probably just not calling it pair reviewing. Um, the This is the best way to sort of stop that synthetic and cognitive debt, like I talked about, and this is a great way to keep your junior engineers sharp as well. Um, and then the other thing, this is a terrible one, right? Work on your soft skills. And what I mean by that is um, there are skills out there that go beyond simply tweaking your code a little bit, right? You can add skills that will add things similar to spec-driven development um, that are soft skills to work on. This is why this is hard to talk about. Talk about linguistic relativity. How do you talk about soft skills to help improve your skills? Yeah, it's sorry. The point is, right, you can go out there, you can look for things that will, like, I'm not going to endorse anything here, but you can look for skills that will do things like grill you on how your code is working or what your commit is going to look like. And I think that's a great way to stop these debts from building up as well. Speaking of de-skilling, okay, um, I've been very critical of AI. You should be critical of anything that's about to go into your repository, right? Any third-party tool deserves to be you deserve to be critical of it, right? Um, but one of the fears I see out there, I see this in this culture. I see this as people realize how quickly they can generate code as they kind of start thinking, oh, like I'm gonna get stupid if I use AI, right? And that's probably not entirely true, right? I think there's a way to do it and not be totally de-skilled, right? You're not going to start pouring Brando on your lawn. Um, so we're going to throw it really, really, really way far back here, talking about problems that we've seen before. This is Socrates. You probably even know this picture. It was probably in your history book back in high school or something. But the only reason we even know about this guy is because he had a student named Plato who wrote everything down. Socrates didn't write anything down because he thought it would make you lazy and dumb. That is true. That is real, which was astonishing to think about, right? And if you think, well, maybe Socrates had some really good points, but kind of like the Max Weber quote, like it's been thousands of years and I write things down a lot, and I think we've progressed pretty far since then. So maybe writing things down is not too bad. In the same way, using LLMs to build software isn't inherently going to make your engineers implode. You're not going to magically like lose IQ points. Um, but at the same time, you have to pay those friction taxes. You have to find ways to stay in charge and understand the code so that you don't run into this descaling problem. Put another way, we still need to do things the right way. Okay. Nobody laughed at this one. I told you the jokes got worse. All right. All right. Okay. So one of the ways I think you can really take control of your engineering culture and how your team works um, around AI is through this use of agent harnesses, right? I really encourage you to build and use your own harness. We talk about what's in a name. I love that the fact that they call it an agent harness because a harness is something, right, that you can kind of use to restrain or pull something back. And when you build your own harness, you get this ability to expand the level of human in your loop, right? When you build your own harness, you get access to all these phases, right? You essentially get state management over the process of how your software and your code's being generated. And it allows you to introduce friction wherever you want, hypothetically, um, to make sure that you do those things like understand the code. You can make sure that you check for intent. You can keep your skills sharp, right? Um, this is a really long quote. I won't read the whole thing, but I thought this was something that kind of summarized and provided a really succinct loop. Succinct, it's quite long, but um, about the idea of harnesses and theory building, right? Um, as, as human developers, we bring our skills and experience as an implicit harness to every code base, right? And that's kind of what I was talking about earlier with this anthropomorphic gap, right? Gap. As human developers, we bring this experience, right? We bring this tacit knowledge and understanding of our customers' problems, understanding of our users' problems that you can't really impart into an LLM. Um, this is the one that I'll read this whole one to you because I think this is the best part. This is Brigitte Bokler, distinguished engineer at ThoughtWorks. A coding agent has none of this. No social accountability, no aesthetic disgust at a 300-line function, no intuition that we don't do it that way here, and no organizational memory. It doesn't know which convention is load-bearing and which is just habit, or whether the technically correct solution fits what the team is trying to do. Harnesses are an attempt to externalize and make explicit what human developer experience brings to the table. So, um, I don't know if Bokler's ever read the Programming as Theory Buildings, but I think that sort of reinforces that idea that when we work in the LLM space, when we work with AI assisted coding, we don't always have that theory built. And if we remove ourselves too far from that, right? If we try to go too frictionless and trying to optimize our workflows around pure speed, we sort of lose this culture around what is actually successful software, right? And I want to talk a little bit about how this ends up. You know, you've heard me talk about outcome, good software, blah, blah, blah. You know, how does that actually show up for your users? How does that show up for your customers? Um, so this is sort of my take on the downstream consequences of theory loss, right? When you lose tacit knowledge or a feel for the game, you lose the ability to solve software problems, okay? When you lose that culture, you lose what it takes to be successful in that same way. Okay. And there's a French sociologist who has a great term for this, but I like to call it ball knowledge. Okay. This is Pierre Bourdieu. He said, this is 1970s. He said, habitus, which is this idea that, you know, you have some sort of cultural or muscle memory developed from living in a cultural. He defined it as something a little bit more elegant. That's habitus allows the individual person to consider and resolve problems based upon gut feeling and intuition, right? And in the same way that you don't build ball knowledge without the friction of arguing with people on Twitter, right? You can't build habitus and engineering culture without points of friction. So we'll do a short hypothetical scenario and then a long one, right? How many times has it been that you wake up, you're on call, you get that alarm, you look at the error that's being thrown, you look at whatever the incident title is, and you know, like right away, sorry, you know right away, oh, this is X service throwing an error upstream, right? You know instantly, like I know exactly what function I'm going to go into, where I'm going to change this statement, and I'm going to fix this problem, and it's going to take about however long it really takes to deploy my program. When you lose habitus, right? When you lose your culture, when you focus and remove all points of friction, you lose that ability, right? When you lose theory, you lose service profit chain, okay? So Think about it like this. Maybe you're listening to me and you're saying, you know what, you've got excellent taste in niche French sociologists, and I want to take this back to my team, and I want to tell my CEO and my stakeholders and all these people, like, we need to start thinking about these things. But they do not care too much about technology philosophy, right? They want the speed of it. How do I sell this message, Jared, to my stakeholders? This is it, the service profit chain, okay? The service profit chain states that profit and growth are stimulated primarily by customer loyalty. Loyalty is a result of customer satisfaction. Satisfaction is driven by value, and value is driven by employees. This is a chart of the very same thing, and I think this was also, I think, maybe an early 2000s economist put this out there. I think it was a group of economists studying it, like Harvard or something. Um, but you can see the top, it says internal service quality. Okay, that is where this all starts. It all starts at internal service quality. Um, to expand on that hypothetical scenario earlier, right? You got the call, you're jumping up out of your bed, you're going to go solve this problem, but you have way too much synthetic debt. You've got way too much cognitive debt, okay? You've got a shopper that's sitting at the store, okay? This is a kid trying to pay, for books for his school. He wants to go home. It's 8:45, Publix closes at 9. He wants to go home and like play League of Legends with his friends. Um, there's a member that's urgent waiting on this order. Maybe it's got cupcakes or something for their kid's birthday tomorrow. They can't check out, right? So they call the support line and they say, hey, I need some help getting this order processed. Okay. You jump out of bed, the support agent's telling you, I've got this order number right here. And you get on there, and what was an instant fix, right, is now a massive spelunk into a repository that you don't understand, right? You took a 5-minute solution and it's now 5 hours. Okay. Publix closes, you lose your shopper, they go to work somewhere else, you lose your member, they start going to order from Instacart or something, right? And then you lose the trust of your peers. You get in the elevator the next day and the support agent kind of looks at you like this, and it's not comfortable, okay? It's a long elevator ride to the 10th floor. Um, so that's where you start, right? You start all the way up here, you start at the top, and when you sever this, you lose all these things. Put another way, when you sever that theory, you lose internal service quality and you lose customer loyalty. That's why habitus matters. That's why theory building matters. That's why friction matters, okay? The generation of code isn't as important as the human comprehension of the system itself. When you value max, when you put all of your energy and your culture, you start building it around speed and code generation, which we know is not the core of the job. That's not how you create good software, right? You end up delivering a product like this. And when I see this, I always think about like the Game of Thrones seasons, right? Like as the seasons went on and the thing got worse, right? And we were all really upset by the end of that. That's the same thing that's happening here, right? We need to start out with the very detailed horse and end with the detailed horse. They lost this. I don't know, what did they lose here? They lost employee retention and productivity at this point, I guess. That's like a third of the way through. Anyways, um, yes, just to wrap it all up, the true value of an engineering team is no longer the generation of code, right? And I would argue, and Peter now would argue, that it never was. And then in the same way, art is not about paint, right? We talk about engineering problems are human problems, right? When you look at art, you are looking at something that is almost an expression of a human problem itself, right? When we look at this piece by Rothko, we don't think to ourselves like, wow, he got so much paint on the canvas this time. Really well done, buddy. You got 3 colors on there too. Outdone yourself, right? This art, right, is this way of expressing that habitus, right? The way that we value and find meaning in art is the way that we see the artist map human experience, habitus, culture onto this medium, right? The mental map, the same way that Peter now says there's this mental theory, the mental map of what it is to be human, right? Um, in the same way, just because we have more code in our repository, right? Or maybe we have really elegant code and we've got thousands of lines of it, that doesn't mean that we are solving our customers' problems any better, right? If we're not actually helping them resolve issues, right? If we don't have the right friction in place to make sure that we are skilled enough to be able to understand the piece itself, we have no value in it. So to really build the engineering future that people are asking for, not just as consumers, customers, and clients, but as humans, we must also keep humanity in the loop when we build our software. All right, thank you. Did I leave enough time for questions on there? Oh yeah, cool. All right, cool. All right, any questions? Yeah, yeah.
Siblings.
Great talk. You mentioned spec-driven development. That's something I've been thinking about. You mentioned generating the spec and then letting AI code. In your view, do you want AI also generating the spec, or should that be mostly or purely a human-driven thing
I
or
think at
written?
yeah. I think at the very least, I don't know. This is okay. This is what I run into with like agentic engineering in general is to keep with our Shakespeare metaphors. Are you familiar with infinite monkey theorem? Okay. So this is this idea that if you took enough monkeys and put them in rooms with typewriters, they would eventually recreate the work of Shakespeare. And I think when you start trying to let AI like, oh, I'll just let AI think against itself. Like I'll make a bunch of agents and they'll like compete against each other until they get the right solution that I want. That's kind of the same thing, right? You can have the AI do spec for you, but what you're going to find, I think, at least right now, is that it would have just been faster if you did it yourself, or you went to your, your peers and said, "Hey, I want to build something like this. How do I do it?" Um, so to answer your question, you can. Maybe you shouldn't. Maybe you should.
Hey, so I'm a product designer, and now everything that you're talking about is kind of exactly what I've been trying to stress to people when it comes to, especially like user-facing products, keeping humanity in the loop, and actually trying to stress to people that the research that designers do that build good products is super important. So, as a product designer, how do you, taking everything that you've said today, like how would you like to see product design hand off things to engineering better and kind of make it a little bit more easier for us to actually communicate with you guys? Because I feel like product and engineering are so similar, but it seems like they're like two completely different factions and they just kind of hate each other. So
Yeah.
like
Yeah.
how
Yeah.
do we close that gap and kind of like do the necessary things to make your jobs easier?
Yeah. Well, I think you start by focusing on where you're more alike than where you are different, right? Like at the end of the day, you're both trying to build, whatever you think is the right solution for the user, right? You're on the same team, you want the same outcomes, right? So working towards that same outcome, the way I like to work with product is really just as high up the chain as I can get, like inject myself into whatever meeting that starts off this kind of thing. Um, Making sure that that way we communicate the whole time. Like Michael said, like there's a moment in I think project development where you have a surprise and no matter what it's a bad surprise, and that's like where I see product and engineering going wrong is like we didn't talk enough when we started and then suddenly it's out the door or something, right? It's too late. um, and I think when we talk about that in the context of how do we work with that in LLM engineering, I think um, I this is once again, this is my personal opinion, right? I do not ever use AI as a proxy to communicate with another human. I've seen a lot of people do like, oh, all my email responses are going to be like agentic now, right? And I think for me, like if I'm like slacking with a PM or something or a designer, the idea of putting that trust and that relationship in the hands of something, or I mean anyone else really, right, is like I can't do that. So yeah, I just say just making sure that the project kicks off with everyone in the room as close as you can together, and making sure that you build that relationship towards this is the outcome we both want. How do we get there together?
Remember, he's trapped upstage, so you can ask him literally anything.
It's true. Yeah.
Just as long as you get it.
I think probably something a lot of us have noticed is, especially with like everyone's like echo chamber in their LinkedIn feeds and Twitter X feeds, that the expectations of leadership in organizations has changed, and the speed of development. So what have you implemented, at least in the last year, in communication with managing relationships of leaders at your organization in order to protect your team?
Yes. Okay. What have we changed about executive communication in the last year around the expectations of this? I think, once again, don't speak for Shipt, but I will say that the thing that I think we're doing the right way right now is our focus is entirely on learning. Our focus is on, like, is this actually working, right? So the expectation that we have is very different, I think, than the expectation that people are claiming. And, I don't know. I see those things on like Instagram where people are like, I punch my computer until Claude gives me the right answer kind of thing, right? And it's like, that's a little I think it's different because when you open up the democratization of engineering, right? Anyone can build, and the circumstances for everyone and the expectations for everyone are drastically different. Um, and the way to, I think, really communicate, at least, the way I've approached it is like, how are we engaging with learning? Is this valuable? How are we engaging with like, this is what AI is really good at, and this is the part that we need to keep the humanity in the loop or the human in the loop. Um, I think grassroots level is the best way to approach that. Um, every team, in my experience, has one person that is like the AI person. All right, mine's sitting right over there to embarrass him again for like the third time, right? And that's kind of the person where we say like, hey, I want you to take what you have been learning and share that with your peers. And then you say, hey, VP so and so, like the way we're approaching this is we've got this person once a week for an hour getting hands-on keyboard time with our other engineers, and that's how we're building towards that expectation.
Anyone else? Again, he's trapped up there. He literally can't leave for the next 4 minutes.
Mhm.
No? Going once? Going twice? Oh, I knew I'd like shame somebody into doing it.
What would you recommend for people who are just getting into AI, non-engineers, non-technical, who are using AI as something to build and are excited about, something that you do not want to debunk,
Okay.
or
What I would tell them is to go hang out with people like Michael. I'd say go to these base meetups. Okay, go to base stuff. Okay, yeah, hang out,
Do not hang out with me.
yeah. Don't hang out with them, but find those community groups, and find those people that are interested in the things you are, and the people that are like, like Tech Birmingham, Base, all these other organizations in Birmingham that are willing to kind of like help you get your foot in the door or help you elevate your game. Um, because like I said, humanity in the loop, right? Like it's all about we're trying to solve human problems, and you need to find those other people that are out there willing to work towards solving those human problems. And when you find that group, they will help you like elevate your game, so to speak.
Seriously, we have a show and tell first Tuesday every month at Innovation Depot, 11:30. It's conference room C. There are literally no stupid questions. I mean, there are. Everybody knows there are stupid questions, but we're not going to laugh at your stupid questions, because if you like the one of the few things we can fix in the world is ignorance. And if you don't know a thing, like ignorance is, ignorance is such a pejorative, and like, but most of what Jared's been talking about for the last few minutes is fixing ignorance. Like you don't know a thing and then you know it, and now you're not ignorant of the thing anymore. And like, there's no sin in that. There's no shame in not knowing the bajillion things you can't know. So, anybody else? One more, always.
Thank you. I think you did a really good talk, and I really appreciate the nuance that you're bringing to the conversation. Um, I'm not really sure exactly how to put this in a question, but I think part of the thing I've been thinking about is I think we are doing a disservice by kind of anthropomorphizing these LLMs and blurring that line between humanity and like we said, it's not thinking, it's not doing anything. So we said Claude thinks. I think that's part of a problem that we're running into. So like, do you have any thoughts on like how we should be rethinking how we communicate about what AI is doing?
Yeah, that's a great question. I thought about adding something like that in here. Like, is it worth talking about changing our language to try to eliminate this? And I think the if this was a newer field, maybe like we could invest the time into like we're going to talk about it in this way. But the concept of AI, like Isaac Asimov's been writing about this kind of stuff with these features for so long. It's so ingrained in our collective human consciousness that like AI is basically robot person, right? And we know that's not true. That it's really hard to change that perception. So that's kind of like what I talked about, I guess, is the treating the symptoms of that problem you're talking about, right? Like cognitive integrity threshold to try to remove cognitive debt from the system is, I think, to use the other word phrase, like it's the linguistic relativity of like, here is the word to talk about this problem that you're feeling. So now you can take this into your conversations, and maybe you can't change the way people perceive AI, but you can change the way that it affects your systems with the right language. Sorry, this is all very abstract, right? This had to bring in the sociologist for this one, so.
Jared looks like an MMA fighter, but he's actually pretty smart.
Allegedly.
I mean, he's good at talking like he's smart. That's all that matters.
There we go. That's what's important.
That's important. We got one more. We got like 30 seconds.
Okay.
So fast question, fast answer. Walk all the way over here. You could have just called.
Well, yeah. Would you say understanding system design is integral to spec-driven prompting when it comes to Sui?
Yeah, spec-driven development.
Yeah.
Yeah. I think this is I didn't know if I would have time to work this in, but one of the things I thought about talking about was, so I'm 34. Okay, so when I was in high school / junior high, Wikipedia sort of like erupted into the educational world, right? If y'all are my age, you probably remember your teachers being like, if you use Wikipedia, you're gonna become so stupid. Like, none of this stuff's on there is true, right? But once again, like we learned that that wasn't the case because we learned how to use the tool the right way. We learned how to verify and learn that the sources of the information were true, and we learned that there were drawbacks that like, yeah, you can put anything in Wikipedia, right? So in the same way, when you use AI, you will have to learn that new skill, right? Of like, I need to think more about systems now. I'm not going to go as far as to say like everybody needs to be a systems engineer, but I think that the level of expectation for engineers is higher, because I've seen a lot of people saying we should lower expectations, but I think it's the opposite. I think we should expect people to learn more about the raw technical skill now more than ever. So yes and no, to answer your question.
Well waffled. Awesome.
Thank you. All
Give it
right.
up for Jared, everybody.
Thank you.